Alright guys, just go handheld for a minute. We'll just go through some of the machining operations we've got left on this little gearbox housing. On the base here, I've got a couple of keyways that I need to cut. These are for positioning and locating the feet that are going to bolt onto here, which are going to locate onto my saddle. Now, I like to use keyway type location. Bolts aren't too good in shear, so always put a keyway location just to give added support, because this is going to be taking a very small hammering effect as that slotting action is going. So I've got two location keys that I need to machine in onto those feet. Sometimes it's good to look forward to what you may want to do a little bit down the track and try and make allowances for that in your machining. So when those feet go on, I want to maybe mount this onto a milling machine, on my milling machine table, and I want to put a small actuating screw. So I'm just going to cut a little bit of clearance in. I've done a quick layout with that. So we're also going to mill a clearance for that screw that will go on as well. And we've got our drilling and tapping that needs to be done. Let's just have a quick look at that GA anyway, and we'll see what I mean with those feet. So here are the feet that we're going to bolt up. These are the ones that I want the keyway locations for, and I've laid out to a screw that I may want to put in there. That's why I've given that little bit of extra clearance on that screw, because you may put an external nut on that. These I want to turn into slideways. If we do put it on a milling machine, hence I've got the little cutouts in here for a slideway arrangement to be made up to fit onto that, but that's a little bit further down the track. I bolt through these slideways too, or these fixed slides, to secure this onto my saddle as well. So let's see what it looks like from the side there. I'm also putting a keyway onto the bottom of this to locate and register up against the side of my saddle, so that any slotting action that's occurring, well, it's going to be on this side actually, any slotting action that's occurring, the forces coming back, it's going to be located against that. It's not going to be trying to move backwards and forwards. So with these keyways, because they're going to start positioning things, we need to have these keys at exactly 90 degrees to the face. So I've gone through and I've clocked up that face, and that's just no movement on the dial. So it's less than 0.005 millimeter. So I've got that very accurate. We'll go ahead next and I'll get this centered up so I can get my cutting tool from the center, and then we'll do our offset for our keyways that need to go into this. I'm going to size these using my little gauge blocks, so I'm going to go undersize on the key, on the milling cutter I should say, and then we'll side cut until we get that gauge just right. So we'll get that centered up. We'll get our reference position set up, coming back in the Y direction, and we'll center up for the X direction. So we'll get set up for that now, and we'll get the camera fixed off, and we'll go through those keyways first, and we'll do the drilling and tapping on the bottom here. Righto, so we've got this offset 41 millimeters. I've got my 0 points I'm going to bring the cutter back to allow a 6mm clearance on the front face and a 6mm clearance on the back face. I'm going to go to a depth of 2.5mm. I might have mentioned one other time that I like to use M mills for slotting. Slot drills tend to drag the chips around and give that horrible jagged edge. M mills don't seem to do that. They seem to clear the chips a lot better. And also with the N mills or with a slot drill, often when you plunge it in, you start cutting, it will bias off one way very slightly towards the end when you finish the cut, and you come back and you'll see just a little bit of an offset in it. It's exaggerated, but M mills don't tend to do that either. So I like to use N mills for cutting slots. Seem to give a much better feel for it. Maybe that's just me, but yeah, it's just my preference. Bit of goo on that. The depth on this isn't critical. I want to go 2.5. That gives me about a millimetre clearance on the actual shell then. The last thing I want to do is break through. so it's just touching now. Just touching on that now. Alright, let's bring that down. Alright. It's come down to a depth of about 2.2. Just about 0.3 to clean off the base on that side. Back to a 0. About 0.2 on that to clean up in the end. Right, we'll just do a size check on that. We'll see how close that is. Right, I've got a 6mm gauge block here, and it's a tight fit, but it's just going down inside it. So it's important to know that I'm not oversized. It's just touching in. I'm not oversized, which is fine. So I can base it on a 6mm cut, so it's pretty close with that cutter. We'll come down to depth and then we'll side cut a mil either side. We'll just shy of a mil either side, then we'll come back with our gauge blocks and we'll just recheck that again. Right, now, if they're right, we should only have about 0.04 left to go, 0.02 on each side, but I'll put some gauge blocks together and we'll come back and have a look and see how close we are to that 8mm. Righto, we've got a stack of gauge blocks that just fit in nicely, not just a little bit tightly, so that did go in, but yeah, they're not going. So that's at 7.92. So we've got to come another 0.08 out. So we're going to come 0.04 on one side, 0.04 on the other. That should put us pretty much smack on 8mm. So we'll set up and we'll do that, and we'll see how we go. deburr that, and we'll see how close we are. Alright, we've deburred it, we'll give this a bit of a go. There we go, it does fit. Alright, so that's just a very, very light press fit in there, so that's spot on 8mm, I'm happy with that. These gauge blocks are the way to go to stack them up when you're cutting keyways and you want to get very, very accurate keyways. Whether you're doing with an end mill and the milling machine or you're slotting them, gauge blocks are very good. You can stack them up and find out exactly where you are and what you have to do to bring back the size. So didn't have to stack that up, it just fitted in beautifully. Alright, I'll go ahead and I'll cut the next keyway off camera, and then we'll bring you back. We'll cut the relief keyway in here that I want to do for that screw, for possibly setting it up on the table here, and cutting keyways horizontally. And then we'll drill and tap, and we'll finish this base off. Then we'll go around and we'll do all the other drilling and tapping operations that we need to do to finish this housing out. Alright, back soon. Right, so we've got this one done, and this one's just slightly loose of fit, but only just yet. We're only talking microns there. Alright, so that's our keyways done. We'll set up and we'll cut the relief on this bloke next. Alright. Right, we've zeroed off to our face here. I've come down 1.5mm. I've got a 12mm carbide end mill. I'm just going to mill straight through on this. Not critical. It's, as I said, it's only for clearance, so we'll do that now. Righto, all done. We'll deburr that, and we'll get set up for our drilling operations. Right, I might just do a quick pan around. So I've pre-centered all of our tapping holes in the base. And I'm just going to use my didgeridoo on the head, and we just use our coordinate system that we've got zeroed off, and we come down to our datum points to drill. So I'm only going to go down 13mm. I don't like breaking through. I don't think it looks good. If you can try and avoid it and have blind holes, it looks a lot better. Righto. So we've got a 5mm drill in here to tap for an M6. Bring it back to our edge distance, which is 10. And we'll look it off at that. Righto, so I'll go ahead and start tapping these. I don't have a powered tapping head, so I'm just going to set my spring center up here and just do it the old-fashioned way. So I'll go through and tap all those off, and we'll reorientate, and we'll come back for the next type of tapping operation, maybe in the face here. All right, back soon. Right, I just thought I'd show you tapping these holes. When you're using blind holes, it's ideal if you can get one of these spiral taps. They eject the chips out of the hole while they're tapping. These are actually pointed, which is a bit of a pain. I should grind that off because it actually restricts how far you can go to the bottom. The other thing I don't like about these ones, and I got these, I think it was from Banggood, is that once again they don't have a centre in the end there for this little bloke here. You make up an adapter, I guess. I might do that one day. Hence I'm using the T-bar because it actually has a centre inside it. So I've just got my spring centre. If I can get close, there we go. And the Tap Magic, it's very good cutting fluid, this stuff. Does make life a little bit easier. I'll try and stay out of the way of the camera as much as I can. And you can see what I mean by the chips do eject out of the hole as you're tapping it, so they don't get pushed forward and end up crushing into the bottom and restricting the depth of the hole. Now I do like to break it back, just remove some of the debris out of that, and I'll just put a little bit more cutting fluid on there. I'll just rock it backwards and forwards just to get the cutting fluid down. I'll try and do this one-handed. That's it. So I got 2 more to go. And then we're done. Alrighty. Just thought I'd show you that little spiral tap. Alright guys, we'll go through the next set of holes that we're going to do, and with the ISO, it's going to be these holes in the face of that little gearbox housing. So we've got a total of 8 to do, 4 up here, 4 down here for one slideway, 4 here and 4 here for the second slideway. So those slideways, see in the ISO here, are these 2 slides here, which carry the main block housing up and down, allowing us, as we've said in the past, to adjust for different centre heights in lathes, but also to allow us to side cut to open up a keyway width. This side here is a little bit of a pain in that it's got a bridge over that clearance slot that we've had to cut in for the crank arm, so not as rigid as I would like, but there's no way around this. We'll just have to see that pans out. Now these slideways, when we do get to these, I want to bolt these into place and get them squared up, rough machine them out as far as the dovetails go, then set them up, dowel them into place. I prefer keys, but we'll go with dowels. Dowel them into place, and then we'll cut the dovetails in place. But for now, we'll just get these fastener holes drilled and tapped into place, and then we'll move on to the to one of the other sides. All right, so we'll get into that now. Righto, so I'm going to do the fasteners down this side of the housing first. So I've zeroed off on my datum face at the base, and I've zeroed off on one side. So as per the drawing, we've got to come in 7mm from one side, and we've got a series of holes to go up at centres of 10mm, 42mm, 106mm and 142mm. So I'll do all the centre drills first, and then we'll come back on the last of the holes that we're drilling out. the tapping size, which is M6. Alright, back soon. Righto, so we've got all those centre drilled. We'll go through and drill out for the tapping size, which is 5mm for an M6 pitch metric thread. So I'm going to go down about 13mm. Right, while we're over here and we've got our datums all set up in our digi readout, we'll go ahead and get them all tapped out, and then we'll move over to the second side, get them finished out and get them tapped out. Alright guys, we'll start pilot drilled on this side here. We'll go through and we'll drill these out to 5mm, ready for the M6 taps. I don't know if this is going to be able to focus at all, but we'll see. But any drills that I regrind, I always try and split point them if I can. Probably 4 or 5mm is probably the smallest I can go for split pointing with with the condition of my grinder. But yeah, certainly makes a difference if you can do that. Right, we'll just zero that on the head, and then we'll come on down. Righto, we'll go through and we'll tap these out. Mightn't have shown it before, but that's my little spring centre that I have up inside to keep tension on that tap wrench while I'm tapping these holes out. Just does a nice job. And I did grind the point off this M6 spiral tap so I could get a little bit closer to the bottom. So makes life a bit easier. Alright, I'll go ahead and get these all tapped out. Come back on the last couple, and then we'll set up and start doing probably the top face then for the motor mount. I'll get those fasteners drilled in, tapped holes put in. Alright, we're back for the last tapping on this side. That's it, one down. All done. So, yeah, good stuff. It really does make a difference. I remember my father, when he was running his workshop, had his own brews of cutting fluid, and one of his classic ones was the Sunday roast and getting all the dripping and the fat, and then mixing that up with sulphur in a pear tin, and he would use that in the workshop. So whenever you went out, particularly if he was cutting stainless steel, It smelled like a Sunday roast every time you went out there. So memories of when you were younger. But yeah, the tap magic. The one I used to use was the old Triflex in the green tin, and yeah, that used to stink too. All right, so what I'm going to do while I'm throwing things away is we'll go ahead and we'll deburr this all over. So when I'm deburring, I'm pretty slack. I just use a battery drill with a chamfering tool in it. I'll just come back a little bit. It doesn't take much, it's only just a quick nip. And that's it. So all I'll do is I'll just go over that with a stone just to make sure there's no raised burrs on that. Right, we'll get ready for the next drilling and tapping operation at the top there for that swivel motor mount. Alright, we'll be back soon. Alright guys, we'll go through drilling and tapping the top of this housing. Now I found a mistake on this drawing. For some reason all the fastening sets on the top of the housing on the drawing have come out mirrored, so they're on the wrong side of where they need to be. Why that's happened I don't know. I suspect maybe it may be an issue with first angle, first angle when I was pulling the views out. I'm not sure, it's just one of those weirdo things. Now normally these things would be picked up by the checkers in your group, in your team, if you're doing design work. And it's important always to get your work checked by an independent person, someone that you trust within a team. He may be dedicated to just doing checking if it's a large project. But as you can see with all the other views here, those holes all show up on the correct size, but they're on the wrong side here. And the last line of defence often is the fabricator, the machinist. You need to have a lot of trust in that fabricator, that they'll pick these little things up as the last line of defence, rather than just looking at these parrot fashion. Actually look at how things go together, and they've got an idea in their head, and sometimes these things can be picked up at the machine shop level before any mistakes get made. So I've updated the drawing. Those holes now are now mirrored over where they're supposed to be. And it's probably a little bit hard to see on this drawing, but just on the plan view here you can see the motor mounts here, and these are not actually the motor mounts, they're supporting a pivot assembly to allow that motor to pivot up and down to do our belt tensioning. So we've only got 4 to do, and then we've also got the filler hole, which we'll do while we're here as well for the oil. Alright. I guess there is one time that checking is absolutely critical and workshops can't pick it out, is when you've signed a disclosure contract, non-disclosure contract. And I've worked on these before, and they're absolutely painful, where the owner that you're doing the work for has asked that drawings not go to a single manufacturer, and they're spread between 3 or 4 separate manufacturers. The drawings go out with no titles as such. The manufacturer has no idea what the tolerance sets are, or what the fitment sets are from one component to another, and you've got to be absolutely spot on, particularly if it's a rather complicated piece of kit that you've designed. You've got to be absolutely spot on with your tolerancing, absolutely spot on with the way things go together. You've got to make that absolutely spot on. It's difficult for the fabricator working like that because he doesn't know what goes with what, but sometimes with these non-disclosure contracts that you sign, sometimes that's the way you've got to run the show, and you've really got to be on the ball and go out and do your inspections. Really, really important, because it's just so easy to have mistakes made when you're trying to work that way. Not the case here. This is my own design, so if I make mistakes, it's my own fault. And fortunately, I'm doing my own checks as I go as the machine shop operator, and find the mistakes. All right, so we'll get this this all zeroed up, and we'll start drilling and tapping those holes for those motor mounts. Right, we've come off with a little bit of a problem here. What I'm drilling and tapping into is right on the boundary of that weld, so it's quite hard, and I snapped off the end of my center drill down inside here, so I've just spent the last half hour picking and working it out. I put a carbide spot drill in there, and I was able to get just about all of it out and just take it very easy, but the M5 drill I put down, you can tell that it's hard. It did struggle going through that boundary area where it has hardened up due to that weld, so I'm just going to be very careful when I'm drilling these and when I'm tapping these. The last thing I'm going to do is break a tap off in any of these holes here. I haven't got a lot of movability where I can replace these because everything's very tight around here at the moment, but we'll get set up and we'll drill those that 5mm hole. Hey guys, just finishing off this this last tapping hole now. That's it. Now these three here went quite well. This end one here was really difficult, and I suspect with that weld, because it's at the edge of the box, it's chilled out a little bit and gone a little bit harder than these other ones, and it's caught me out. Alright, so the rest of them went quite well. Really uneventful, but honestly it's a real pain if and we've all been there, we've broken a tap off or a drill bit off or something inside a hole. Probably yeah, one of the nastiest things that can happen in the workshop. But yeah, got out of this one fairly easily, I think, compared to what it could have been. Alright, I'll deburr these. The next job we're going to start, I will drill the I will drill in here the fill hole. I might have to move that clamp back a little bit. I'll drill that fill hole in, tap that. We'll flip him up on his side, and we'll start doing the drilling and tapping on the PCD for the bearing covers. So we'll get into that next. But before I break this down, I'll drill that filler. Right, we'll go ahead and we'll tap this out. This is a tapered plug. A little bit of gut feel, just got to feel it out. I want to make sure that it's going to pull up on the tape. I haven't got a plug, I've actually got a fitting here that I'll use to gauge it. But we actually want that to tighten up on the thread, not on the head for the PSP. T-tapered fitting, so we'll just go very slowly and we'll just cut that in. I knew that was going to happen. Hitting the head of the nut. Let's just see how that looks. It's only a very thin wall here. It's about 4mm thick. That's what it's down to. Give it a blow out. See how that looks. Yeah, a bit more yet. That's pretty tight. we'll go a tad more. See if it feels any better. Yep, I'm happy with that. I'll leave that at that. You can always take it out a tad more if we have to, but I think that'll be pretty close, particularly with the brass plug. Alright, I'll go through, deburr these out, and as I said, we'll get set up for the side PCDs on those bearing caps, bearing covers.